I'll touch on some of the things that we're doing on beef efficiency. This is a program funded by the government to implement a system of using phenotype farms to record feed intake for the beef industry. We're leaning on results from here and from Australia, saying that feed efficiency is a good thing. There's a lot of the stuff done by John Bazab and his group. There's lots of reasons why you would reduce feed intake or improve feed efficiency. These are the bins that we use in the research herd, but these are the ones that are actually on the farm. Now, this is a farm. There are 2 farms where they've been contracted by the project to farm phenotypes. They have no control over the animals. They have no control over the system. They simply follow a recipe that we give them. They feed the animals. They record the feed intake. We pay them. Thank you very much. And those results are then used in the feed efficiency program. And we think probably this is the way that things might go in the future for some of these expensive and difficult to measure traits. Now, on the dairy feed intake side, we have a project also running with Filippo here and his group, Genomes Canada project. And I mentioned earlier about the use of milk mid-infrared. This is how it works. Normally, a milk recorded herd would have milk samples taken. They go off to the lab, and the machine that produces how much fat and protein is in the milk produces it by making that graph on the right-hand side, the spectral data. And from the spectral data, we can predict the fat and protein percent in the milk with an accuracy of about 99.9%. The point of it is, in the old days, they used to throw the mere data away because they were done with it, and it had no other value. In the last few years, we've realized we can use it to predict other things. And what we're doing now is looking at what other things we can predict with it. We can predict about 35 separate amino acids, fatty acids, so we can do things like saturated and unsaturated fat in milk. We're about, or have gone live, with predictions of ketosis. So the milk recording organisation can now offer a service to dairy farmers to predict which cows are likely to be in negative energy balance or positive energy balance. And one of the things that us and the Irish and Filippo's group are looking at is how to predict energy intake or feed intake from this milk mere. And we've done it already on our own data, and you can see here, you can produce breeding values. These are, in the UK, we call them PTAs, EBVs for energy intake. And you can see that there's generally a trend, kind of a downward trend. As the bull has got a higher overall economic index, his breeding value for feed intake is going down, generally. You can see that. But at any one, on the right-hand side, at any one given level of PLI, there's a large variation in the breeding value for feed intake. So there are bulls that have high PLI and high feed intake, and there are bulls with low PLIs with high feed intake. This is a good sign for us, which tells us that we've got something we can select on. And you can see these bulls on the right-hand side. These you will know who these bulls are. They're top international bulls, and you can see some of them have got negative feed intake or energy intake breeding values, and some have got positive. So there again is opportunity for a farmer to make selection decisions on feed intake with high-producing bulls. So we're also engaged in the international activity in producing a genomic breeding value for feed intake. So the reason for kind of listing them out is to show that we're very interested in efficiency in the UK, and we're looking at it from a number of different ways. We're using genomic predictors based on international activity for dairy bulls. We're looking at predictors from milk mere for feed intake in dairy cows. We're looking at carcass trait characteristics for both beef and dairy bulls to look about how we can optimize the flow of better genes across the dairy and the beef herd. So we have a great deal of interest in putting all that together and providing tools to both our dairy and our beef farmers that they can use to optimize carcass characteristics and feed efficiency at the same time. Now, I just want to finish off with a little bit here that's of interest, and it will be of interest to you as well. So when we start looking at feed efficiency, we start thinking about the dairy herd and the beef herd. And what we did is that we used insemination records and conformation scores of bulls, because you can actually predict live weight from conformation scores with an accuracy of about 85%. It's a really good predictor. And we converted the linear type trait scores into live weight and then multiplied it by the number of inseminations of the bulls and then calculated a kind of a national live weight total of the dairy herd. And this is the outcome. This graph shows that whatever we do, the national herd will increase in size over the next 5 years. Okay, so we've got more kilograms of cow in the UK, and we'll have more kilograms of cow running around for the next 5 years. You can see it levels off a little bit at the end, but the kind of kilogram, I think if I'm not mistaken, it's about 4,000 tons. So now what that tells me in terms of efficiency is that for them to remain the same efficiency in 5 years' time as they are now, they've got to produce more milk or be more efficient to the tune of 4,000 tons. They've got to accommodate for their own weight increase of 4,000 tons. Now, I suspect you have the same situation. And I'd be interested to know, I know Brian's here, or was here anyway, I'd be interested to know whether this is a similar situation, because we import an awful lot of the semen that we use in the UK from North America. And partly this is a result of genetic trends in other parts of the world. So I slotted this one in last night. I just point out that like in Ireland they're genotyping 1 million animals over the next 3 or 4 years. And the Scottish government have copied them, but we're genotyping only 20% of our beef calves. So in a few years' time, we should end up with around about 100,000 genotypes that have been collected almost free of charge. It's part of a kind of an EU Pillar 2 payment scheme that allows farmers to be paid to genotype their animals. So again, we've got a bit of a momentum going, and we should end up with a large number of genotypes in the future to do that. So the story that I've told you, just to sort of summarise, is about half of UK beef comes from the dairy herd. Cows are getting bigger but not more muscular, so they're becoming less efficient. We're going to try to rectify that by producing carcass trait EBVs, and we're utilising as much information as we can from different sources to improve the efficiency. We have national phenotype farms for beef, which will lead to feed intake, EBVs, and subsequently genomic breeding values. We've got Scottish national genotypes, and we're utilising efficiency measures across dairy and beef in order to try to improve the overall situation. All of that you've seen before. Right at the bottom, Brexit is here. We're going to be leaving the EU, so we're going to be confronting a different set of problems in the future. We're going to have some different challenges, we're going to have some different opportunities. But as I said right at the very start, I think the problems and opportunities that we're confronting in the UK are very, very similar to those that you have here in Canada.